Hello, and thanks for joining me for a 6LoWPAN tutorial. 6LoWPAN is connecting more things to the cloud. Low power, IP-driven nodes, and large mesh network support makes this technology a great option for an Internet of Things application. Today, I will introduce to you the 6LoWPAN standard and present to you some development resources, including the open source Contiki implementation on TI's low-power RF devices. So let's begin. So what is 6LoWPAN? 6LoWPAN stands for IPv6 over low-power wireless personal area network. The principal idea with the 6LoWPAN standard is that Internet Protocol packets can be carried efficiently within small link layer frames. This means that 6LoWPAN should be used with low-power wireless networks with memory-constrained embedded devices. It is also being adapted and used over a variety of other networking media, including sub-1 GHz low-power RF, Bluetooth Smart, power line control, and low-power Wi-Fi. A 6LoWPAN system is normally composed of many low-power nodes in a self-healing mesh form. This means that data can be exchanged freely by using an edge router, which acts as a simple gateway to the rest of the Internet. Applications running on the nodes can pass IP packets to a server on the Internet without thinking about the edge router, which just relays the packets from the 6LoWPAN network to the Internet. There are three distinct advantages to a 6LoWPAN system. Firstly, 6LoWPAN uses open IP standards. This includes many well-known standards such as TCP, UDP, HTTP, and WebSockets that many developers are already familiar with. Another advantage is the lack of an application layer gateway. The only functionality that is needed on the edge router is a bridge between the RF and Ethernet network. This bridge is incorporated in the 6LoWPAN stack, allowing transparent Internet integration. Secondly, mesh routing enables networks to become more robust with large size because more nodes can talk to one another. The network is self-healing and performance can be optimized for either hop count or link quality. If a transmission path between two nodes is broken, a new path will automatically form. Thirdly, 6LoWPAN supports multiple physical layers as well as frequency bands, and interoperability is only enforced at the IP layer. This means that both sub-1 GHz and 2.4 GHz hardware solutions are possible. Now that we understand some advantages, let's go into some applications. 6LoWPAN can be any low-power wireless node that needs to be connected to the Internet. Each node receives an IPv6 address and can be reached in the same manner as any other server on the Internet. You can literally ping each node. Lighting, both residential and commercial, easily becomes a network with a large number of wireless nodes. 6LoWPAN benefits from this large mesh network type routing, allowing increased RF coverage and system robustness. An example product in the market is the wireless LED light bulb made by LifeX. Also, home automation with Internet connectivity and interaction between devices is gaining momentum in the market. An example of an upcoming home automation tool using 6LoWPAN is the Tado Smart Thermostat. Now that we understand the applications, let's dive deeper into some of the products. The most popular wireless MCU from TI used for 6LoWPAN is the CC2538. It can be used standalone for a 2.4 GHz operation or with the CC1200 for a sub-1 GHz operation. For applications that require longer range or better sensitivity, there is an option to extend RF range between wireless nodes with TI's integrated range extenders. The CC2592 is used for 2.4 GHz and the CC1190 is used for sub-1 GHz operations. Kentucky is an open source operating system which incorporates a complete 6LoWPAN stack. All TI development efforts on Kentucky are contributed to the Kentucky community, and we continue to add new platforms and enhancements all the time. The MCU resources required to run Kentucky are modest, and the complete software stack and tools are available as a one-click download on the website. On the TI Wiki, there are also demos available with multiple cloud vendors. TI has a network of cloud service partners who can demonstrate cloud solutions based on TI hardware. There are step-by-step demos available on 6LoWPAN with ThingSquare on the TI Wiki. For more info on our cloud partners, please visit ti.com/IoT. Now, let's talk about some software tools and development kits that you can use to get started. There are a number of software tools available free of charge on Kentucky, including the GCC compiler, the Kuja network simulator, and the Wireshark packet sniffer. All of these tools are available as a one-click download free of charge from ThingSquare. For more information, go to the TI 6LoWPAN wiki, where you can find the download link. TI offers many development kits to help you get started. First, you will need to choose your frequency band. There is a 2.4 GHz option or a sub-1 GHz option. Secondly, depending on your application, whether it's a node or an edge router, you will need to choose the appropriate development tool. Lastly, for range extenders, there is also a kit available for either 2.4 GHz or sub-1 GHz. So now that you have an introduction tutorial to 6LoWPAN, let's get you started. On ti.com/6LoWPAN, you will find the latest and greatest wireless MCUs, development kits, as well as benefits and features to help make your selection process easier. The TI 6LoWPAN wiki has all the information you need to know to get started, including links to download software and how-to guides. It also includes a step-by-step cloud service demo by ThingSquare. Lastly, our wireless team at TI is dedicated to providing the best in-class support, which is why we have an engineer-to-engineer forum to answer all your questions in a timely fashion. Also, as a member of the forum, you will have access to all previously answered questions. And that's it for me today. Thank you for watching, and I hope you learned something interesting about 6LoWPAN.